Welcome to our video, Oceans in Acid, the hidden impact of carbon dioxide on marine life. As atmospheric carbon dioxide levels rise, our oceans are absorbing more of this gas, leading to a phenomenon known as ocean acidification. In this video, we will explore how this change is affecting marine ecosystems, from the delicate balance of coral reefs to the broader implications for fish populations and food chains. Additionally, we'll address the economic consequences of these environmental shifts and discuss the relationship between ocean acidification and global warming, as well as potential mitigation efforts. Join us as we uncover the critical challenges facing our oceans and the life they sustain. 1. What is ocean acidification? Ocean acidification is a lesser-known yet significant environmental issue that is quietly affecting our planet's oceans. It occurs when carbon dioxide, CO, from the atmosphere dissolves in seawater, leading to a chemical reaction that reduces the pH level of the water. This process makes the ocean more acidic, subtly altering the delicate balance of marine ecosystems. Imagine adding lemon juice to a glass of water. It becomes tangy and acidic. Similarly, the ocean's chemistry is shifting, but on a much larger scale. This change is happening at an alarming rate, with potential consequences for countless marine species and the ecosystems they inhabit. 2. Impact on marine life. The increasing acidity of the ocean poses a grave threat to marine organisms, particularly those with calcium carbonate shells or skeletons. Species such as corals, mollusks, and some plankton struggle to maintain their shells in more acidic conditions. It's akin to trying to build a sandcastle with wet sand. The structure just doesn't hold up well. The acidified water interferes with their ability to extract the necessary minerals from the water, compromising their growth and survival. As these organisms form the foundation of the marine food web, their decline could have cascading effects throughout the ecosystem. 3. Coral reefs at risk. Coral reefs, often referred to as the rainforests of the sea, are particularly vulnerable to the effects of ocean acidification. These vibrant ecosystems are already under pressure from warming seas and pollution. Acidification adds another layer of stress, potentially leading to coral bleaching, where corals lose their vibrant colors and essential symbiotic algae. This bleaching weakens the corals, making them more susceptible to disease and hindering their ability to recover. The loss of coral reefs would not only mean a reduction in biodiversity but also the loss of natural barriers that protect coastlines from storms and erosion. 4. Effects on fish. Fish, integral to marine ecosystems and human diets, are not immune to the effects of ocean acidification. The changing chemistry of seawater can affect fish behavior and physiology, disrupting their ability to detect predators, find food, and communicate. Imagine trying to navigate a maze while wearing foggy glasses. That's how fish might feel in acidified waters. This disruption can lead to decreased survival rates and ultimately affect fish populations. As fish are crucial components of marine food webs, their decline could have far-reaching impacts on the balance of ocean ecosystems. 5. Impact on food chains. Ocean acidification doesn't just affect individual species. It has the potential to disrupt entire food chains. Many marine organisms rely on shell-forming species for food and habitat. As these foundational species dwindle, the ripple effects can be felt throughout the food web. For example, a decline in plankton populations could affect small fish that feed on them, which in turn impacts larger predators like tuna and sharks. This chain reaction threatens the stability of marine ecosystems and could have dire consequences for species diversity and abundance. 6. Economic consequences. The economic implications of ocean acidification are profound, particularly for industries dependent on marine resources. Fisheries and aquaculture are at the forefront of this crisis, as declining shellfish populations could lead to reduced harvests and increased prices. Coastal communities that rely on fishing for their livelihoods may face economic hardships as a result. Tourism, too, could be affected by the loss of vibrant coral reefs that draw millions of visitors each year. The economic ripple effects of ocean acidification underscore the need for urgent action to protect these valuable resources. 7. Global warming connection. Ocean acidification is intrinsically linked to the broader issue of climate change. As carbon dioxide levels in the atmosphere rise due to human activities, the oceans absorb about a quarter of these emissions. This absorption helps mitigate the effects of climate change on land, but at a significant cost to marine life. It's like using a sponge to soak up a spill. Eventually, the sponge becomes saturated. The oceans are reaching their capacity to buffer these emissions, highlighting the urgent need to address carbon dioxide emissions at their source. 8. Mitigation effort. Addressing ocean acidification requires global efforts to reduce carbon dioxide emissions and protect marine ecosystems. Transitioning to renewable energy sources, improving energy efficiency, and conserving natural carbon sinks like forests are essential steps. Additionally, protecting marine habitats and promoting sustainable fishing practices can help bolster ecosystem resilience. Public awareness and policy changes are crucial in driving these efforts forward. By taking action now, we can work towards preserving the health of our oceans and ensuring the survival of the myriad species that call them home.